Welcome. This is Dr. Michio Kaku, Professor of Theoretical Physics at the City College and the Graduate Center of the City University of New York, and this is Exploration.
Every week on Exploration, we discuss the fascinating world of science and its impact on your life. Now, have you noticed that the weather is getting wackier and wackier? We're seeing gigantic hurricanes, massive flooding, droughts. We're seeing the weather of the earth being thrown into turmoil. And people begin to ask the question, well, is this global warming? Well, let me be very blunt about this. There's no smoking gun. You can't point to one hurricane or one drought or one flood and say, aha, that's the fingerprint of global warming. However, all the indicators point in one direction, and that is the earth is heating up, meaning that there's more energy in the atmosphere of the earth, meaning that there's more energy sloshing around, meaning that there's more moisture in the air, which can create massive flooding and also droughts at the same time. So in some sense, global warming is a misnomer. It should be called global swings. Now with us today are two experts on the question of, well, is the earth beginning to thaw out? Our first special guest is Peter Ward, author of a disturbing book called Flooded Earth. And then in the second half of Exploration, we're going to bring on another author, David Archer, author of the book The Long Thaw. And so the question we're going to be asking today is, not only is the Earth heating up, but what does it mean if the polar ice caps begin to melt, if the glaciers begin to recede, if sea levels begin to rise, and we have to have dikes, levees, and all sorts of different kinds of sea barriers to protect ourselves against the flooded Earth. And so once again, our first special guest is Peter Ward, author of Flooded Earth. And now I'd like to introduce our special guest for today. He's Professor Peter Ward. He's a professor of biology and earth and space science at the University of Washington in Seattle. The book is rather disturbing and is hitting the bookshelves this week. The book is called The Flooded Earth, Our Future in a World Without Ice Caps. Now, on Exploration, of course, we've had programs about global warming. We've talked about the effect on population and on agriculture and on tropical diseases. But here's a book that talks specifically about how our cities, some of our major cities, will go underwater or may have to be abandoned because of global warming. The book is controversial. However, it gives you a frame of reference as to what scientists are thinking if sea levels continue to rise, not 1 foot, 2 foot, but 5, 6, 7, 8 feet above normal. What happens to our great cities? What about warfare between nations when national borders begin to collapse because of mass migrations of hundreds of millions of people? Something to think about. Once again, the book is called The Flooded Earth. Okay, well, the engineer gave us the go-ahead, so let's start with the first question. Oh, the first question that we always ask our guests is, how did you, as a youth now, get interested in science? So I'll lead off with that question. So, dig back to the cobwebs and think about what it was as a child that set you off in the direction of science. Okay, so the engineer said we're going to start in 10 seconds with that first question about you as a youth. Professor Ward, you're a professor of biology and earth and space science at the University of Washington in Seattle. However, as a youth, what steered you in the direction of science?
Well, thanks so much for having me. And I think scientists know from an early age that they're going to be scientists, so it was indeed youth. What got me going were dinosaurs. My mother and father were from New York. I grew up in Seattle. We didn't have a single dinosaur skeleton, and so I was given this guilt treatment that I had to be in Seattle, and it's my fault or something that there were no dinosaur skeletons. But that got me going.
Okay, and that set you off. And how did you get interested in astronomy and earth and space science?
Well, I certainly started in paleontology, so I was looking at my feet all the time down at the ground. But it became evident, I think, in the first part of this century, or really the end of the 20th century, that there was a great deal to learn about life in space and especially how other Earth could be constructed from what we knew in our own Earth history. And so deep Earth history can inform us about astrobiology. And in the book I've just done now, it is deep Earth history which can inform us about what climate change is capable of.
Okay, well, the book is called The Flooded Earth, Our Future in a World Without Ice Caps. So let's start with the ice caps. The North Polar region, over the past 50 years, since submarines have visited the North Pole, seems to have decreased by 50% just in the last 50 years. So what is your projection of the North Pole and also Greenland going into the future?
Well, the great dream of the Europeans coming to North America was for the Northwest Passage. I mean, this was a driving impulse to try to find a quick trade route to China. We're going to have that. But what I really didn't understand thoroughly enough was the difference between an ice cap and an ice sheet. All of the North Polar ice cap can melt away, and it will have no effect, essentially, on sea level. It is the ice on land, the ice sheets, which are the biggest of which, of course, are Greenland and in Antarctica. Anything that melts on those goes directly into the ocean and raises the level of it. And the biggest, scariest scenario is equivalent to what we call an ice sheet collapse. So imagine you have a cup of really warm water and then dump in about 10 or 15 ice cubes, and up goes the level of that water really fast. Well, that is the scenario for an ice sheet collapse in Antarctica.
Okay, well, we've heard about what's happening in the North Polar region, but in the South Pole, we have huge chunks of ice breaking off. But what does that mean, given the fact that most of the South Pole seems stable, at least temporarily?
You know, I've come back from 2 separate trips to Antarctica over the last 2 years, and we're looking at deep time events of the climate down there, but you can't help but notice what's going on all around you. It was melting like crazy. When you have both kinds of ice down there, you've got floating ice, which again, if that melts, doesn't matter. But you've also got all this ice on land. When it melts, the water goes down to the ice rock contact, of course, and that acts as a lubricant. So when you have really anomalous warming, stuff that is on the edge of this can calve off into the ocean. That causes great global change in terms of sea level rise.
Okay, and talking about sea level rise, doesn't the heating of the Earth itself cause expansion of warm water, which causes the sea level to rise? Just the sheer fact that the Earth is warming up.
It sure does. And matter of fact, if we stopped all emissions right now, we just went completely emission neutral, the ocean is still going to rise in its level because of thermal expansion. There's been so much warming already that the ocean has a lag effect, but over the next 40, 50 years, we could expect nearly a 3-foot sea level rise if, based on the temperatures that we have now and the continued warming. Just from the thermal expansion, no ice at all.
Okay, 3-foot rise without any ice, and I guess for every 1 foot vertical that you lose, how much horizontal seacoast do you lose?
Well, the seacoast itself is affected more strongly by storm surge. And you can think of storm surge as equivalent to going off a diving board. You jump off a diving board at a given height, but if you bounce a couple of times, you go way higher. It's as if you have a launching platform as sea level rises. The storm surge, which are the nasty big waves that rise higher than normal sea level, can hit coasts. But the sideways movement of the ocean is far more serious in terms of what its salt does. Salt goes laterally quite easily, and depending on the type of soil, it is the salinization of the sea level crops that I think is the greatest single danger from sea level rise. It's stunning how much of the world's productivity, and especially the rice regions in Southeast Asia, are on deltas. A delta is built out from a river hitting a calm ocean. If you have a 3-foot sea level rise, every delta on this planet will disappear. We're talking about the Nile, the Brahmaputra, the Mekong, and these are all enormously productive areas. So this is the big blow that is coming. The equation is we're going to have a rise in sea level at the same time we have a rise in human population. As you know, we're at 6.6 billion now, but we're heading towards 9 billion. And this, too, is built into the system. It's kind of like the warmth of the ocean. We could do tremendous birth control efforts now, but we're probably still going to hit that 9 billion. So the intersection of 9 billion with reduced agricultural yields because of the sea level rise is the scariest aspect.
Okay, well, let's assume that we do nothing. That is, we simply treat everything as normal. We keep on spewing carbon dioxide into the atmosphere. Let's take the world 2050. In 2050, what will coastal cities like Boston, New York, Miami, Los Angeles, San Francisco, Seattle, what will they look like if we just keep spewing carbon dioxide in the air as if there was nothing wrong, and we project 50 years into the future?
Well, 2050 is still not going to be apparent that we're in a crisis. It's kind of like watching a speed car as it leaves the Indy 500. If you catch it in the first 10 feet or so, it's not going very fast. But acceleration is an interesting thing. It will be apparent to all city planners in 2050 that something new is going on, and they won't like it. Much of city infrastructure is now buried. People put down, obviously, all the sewage, but now so much of the electrical and advanced communication systems are underground. They were not engineered for salt water. They were engineered for fresh water. Bringing a lot of salt into city infrastructure is going to be a huge headache. It's also going to be a headache for trying to keep freshwater reservoirs going and freshwater aquifers. So 2050 is the time when the alarm bells are going to be ringing. The populace isn't going to see much. It might only be a foot rise by then, but certainly there will be urban red lights going off like crazy.
Well, in New York City, a few years ago, we had a gigantic nor'easter which sent a surge of water into Manhattan, which flooded the subway system. And it was not even a very big storm that did that. And some people think that storm surges, even before sea level rise goes to catastrophic levels, storm surges could paralyze the electrical, the plumbing system, and the infrastructure of a city. What are your thoughts?
Yeah, storm surge is definitely the most dangerous short-term effect of this. Look, we saw what storm surge did to New Orleans. It wasn't so much the hurricane itself, Katrina, that battered New Orleans. It was the storm surge. And once again, your storm surge comes from a mean sea level. When you keep raising that mean sea level, storm surge goes up, way up, higher. The most endangered creatures are therefore freshwater plants. And what I'm really breaking my heart is trying to think what's going to happen to the Everglades. You've got this enormous freshwater biosystem, which will be so threatened by both storm surge and simply rise in sea level. You cannot live in salt water if you're a freshwater plant. And unfortunately, no saltwater plant, like a mangrove, makes food that humans can eat.
Something to think about. Now let's turn the wheels of time to 2100. What will the great cities of the world look like in 2100?
Well, 2100, there will be 3 feet, only 3 feet if we're lucky, and 5 to 6 feet if we're not lucky. And by lucky, I mean we turn off the lights right now. If it is business as usual, and I suspect it might be because of the increased population numbers, there will be that 3 to 5 foot. The most hard hit will be the wharves. Global transport by ship is still the main means of moving great amounts of food around. CNN projected when I was in Antarctica a few months ago that even a 1 foot rise in sea level will cause shipping terminals and ports and docks and dock heights to have to be modified. And their projection was $1 trillion or more by about 2040 just to spend on the docks. Now, San Francisco Airport, I've landed on that airport over and over and over. A 3 to 5 foot sea level rise in the Bay Area will remove that airport entirely. And so just from the economic points of view, that 3 to 5 foot sea level is going to cause such an enormous financial burden on coast cities.
Okay, the big question. Will cities have to be abandoned if sea levels continue to rise 3 to 5 feet? And which cities are we talking about?
Well, we've done a lot of projections on this, and I've been talking to some Dutch engineers. The consensus, and again, this is really just consensus of people looking forward, is that civilization and the cities now could probably absorb a 3-foot, 4-foot, even at the worst case scenario, a 5-foot sea level rise and survive. But anything above 5 to 6 feet for a lot of cities is not survivable. New York has high ground. It can simply move back, but Miami cannot. Miami is I think, the poster child of the type of city that will disappear, as Galveston, Texas will, much of the South Florida cities will, and the Netherlands, of course, is in huge trouble. They're already have a significant, I think it's 30% of the land area is already under sea level, and they spend an appreciable amount of their GNP on dikes every year, dikes and the equivalent of dikes, sometimes big sandbars. When the global economy gets hit hard, it affects everybody, and I think that's what's coming.
Well, what about Boston? Large parts of Boston were reclaimed since the Revolutionary War. If you look at old maps of Boston, large parts of Boston didn't exist until recently. So what's going to happen to Boston?
Yeah, all reclaimed parts of cities are going to go away. The same with my city of Seattle. Our entire bay, Elliott Bay it's called, there's an island. Our major shipping port is an island built up from reclaimed sediment, just as Boston is. And once again, the 3-foot sea level rise allows storm surge, the big storms, to come whipping in and remove a lot of that sediment. You're not going to be able to hold that together. So any city with reclaimed sediment construction, and lots of the airports in Asia, and especially in Japan, they've been building airports out on the water. China's just done it too. All those things will have to be rebuilt somewhere else.
And what about San Francisco, Los Angeles, and especially what's going to happen to New Orleans, where large parts of the city are actually under sea level?
I think New Orleans will have to be abandoned ultimately. It might be a century or two. San Francisco is very interesting. They're very progressive engineers down there, and believe it or not, they have a plan for building a dam right under the Golden Gate Bridge that would save every one of the Bay cities. You could hold off sea level rise by building this dam. Otherwise, it's going to be a whole series of smaller dikes and systems and try to save what you can and lose what otherwise. Los Angeles is in an interesting position, too, because the city itself has obviously a lot of high ground, but there are very low-lying areas in Los Angeles that, again, will be inundated to the point that some huge storm comes, salt water is pushed way inland through storm surge, killing off the plants that are there. And then what do you do when you're living in a house that is flooded out by not fresh water, salt water? A saltwater flooding event is way worse than a freshwater flooding event.
And what about London, where we have gigantic underwater devices to help control the water of the Thames River? Are we all going to be like that? Are we all going to be like the little Dutch boy putting our finger in gigantic dikes that we're going to build around our cities? What are we going to do about this?
Well, the British have thought a lot about sea level rise, too, and they are planning on contingencies for up to 5 feet. And you just really hit it. They're thinking about what sort of engineering do we have to do to save our cities. Historic cities, such as London and any of the cities in the Mediterranean, will do everything and anything to try to keep their shorelines as they are now. But it really all depends on where we can stop this. Look, if we melt every single glacier on the planet, we have a sea level rise of over 200 feet. That was the case less than 17,000 years ago. We know from the deep past that when carbon dioxide has been 1,000 parts per million, there is no ice sheet. And we're at 380, 390 and climbing. It's just, that to me is the spookiest aspect of it all.
Okay, and what's going to happen to growing areas of the world? Like California has the San Joaquin Valley. Other places have gigantic growing areas. What happens when salt water begins to intrude upon these growing areas?
Agriculture becomes very dicey. Obviously, the San Joaquin Valley is enormously threatened. 20 years ago, it was already recognized that there's salt creeping in. Once again, if sea level goes up a little, salt goes sideways a whole lot. And any sort of salt within your soil reduces productivity and ends to the point that you can no longer grow crop plants. So this San Joaquin Valley itself is endangered. The northern Sacramento Valley is in trouble. And as I mentioned earlier, every delta on the planet and all that rice from Southeast Asia, those are the targeted places that we should worry about most agriculturally.
Okay, and well, let's be very specific. I live in Manhattan. Manhattan is a little bit above sea level. The place where I am is about, 15, 20 feet above sea level. However, certain parts of Manhattan are very close to sea level. Wall Street, for example. So what is Manhattan going to look like, and are we going to have to use a system of dikes to prevent the flooding of Manhattan?
Yeah, there will have to be some sort of mitigation going on in Manhattan, if not for the sea level rise itself, certainly for the storm surge. Again, a small level storm surge is the takeoff point for, a small level of sea level rise is the takeoff point for storm surge. And in my book, I actually did some elevation counts for various areas and various streets in New York, and not off the top of my head. I actually projected winners and losers in New York City and its boroughs.
Okay, and let's talk about Venice. Engineers have seriously looked at the problem of Venice. San Marco Plaza, the famous plaza, is actually underwater for parts of the year. So what have we learned by trying to do these gigantic engineering projects like for Venice?
Well, Venice is really interesting because they're putting out into the bay that Venice faces what is sort of a non-traditional dike in a way. It's not like a single wall that the little Dutch boy can put his finger in. But what is interesting and sort of alarming for Venice is also in Holland. It's not just the sea level rise, but it's the fact that the rivers behind yourself. These big cities were often built upon rivers. And because we've got global warming, it's not snowing in many of the mountains. In the Alps and in the Sierra, for instance, snow level is higher. And so instead of snowing in the winter, it rains. And these rivers rise at times they never used to rise before. So Venice is fighting a two-front war, as is many of the Dutch cities. You have to worry about the river that runs through you as much as the sea coming at you. And as any of the military geniuses said, two-front wars are often hard to win.
So Venice may have to be abandoned at some point, you figure?
I would suspect, yes.
Okay, and your book goes beyond 2100, goes to 2300 and beyond. So what is the coastline of the world going to look like now beyond 2100? If I have a map of the world, what will school children see? The North Pole gone? The coastline changing? What will the Earth look like beyond 2100?
Well, it really boils down to some simple geology. Continents, as we know, move around. In the direction that they move, like North America's west coast, there are high mountains generally. But trailing edges, we call them passive edges, don't have mountains, or they have mountains that eroded away, as our east coast does. So you've got the enormous Gulf Plain, you've got the enormous East Coast Plain in front of the Appalachians. There'll be inroads all through that. The problem that we see is that most estimates and models think up to 2100 and stop. But at 2100, if it's business as usual, say we kept it at 3 feet, it doesn't stop there. It keeps going in accelerated fashion. So if you have 3 to 5 feet by 2100, it's not going to mean that you would have twice that by 2200. You could have 3 times that high. The acceleration is the most ominous aspect of this business.
So let's just do a computer program. Assume that at some point we stop greenhouse gases into the future, but we just let the computer program run. What will the world look like? Will all the great cities be underwater by then, by 2200, 2300?
No, ice sheets in Antarctica, they are thinning, and they're thinning in both Greenland and Antarctica. A great deal of that water is going in, but the ice sheets are enormously thick in both places. Greenland is far more endangered than Antarctica is. You're not going to see a wholesale flooding of the cities by 2200 or even 2300, which possibly gives us time, but you're certainly going to see effects where the cities that will have to be abandoned, I think that will already be taking place. We just have to maintain these ice sheets with as much integrity as we can, and that means slowing the global warming temperatures, which seem to be inexorable. Look, we just went through this huge recession. We should have had 2 or 3 years because of the economic downturn when emissions could have been or should have been reduced. They weren't. I mean, they're right up at the IPCC's maximum emission predictions. We're not lowering emissions. We're increasing emissions.
Okay, now let's go into the past. You can do that because we can drill into the ice cap and get ice cores from thousands of years ago. 10,000 years ago, we had the Ice Age. It was very cold 10,000 years and beyond that. So how far back in time do you have to go to find a time similar to what we're going to be experiencing in the future? And what did the world look like at that time?
Well, the conventional answer is that if we get up to 1,000 parts per million, which would happen in 2 centuries from now, if we have some sort of control on emissions, a lot of us think that 1,000 parts per million would be a lot sooner than that. But you're going all the way back to a time called the Eocene. And the Eocene was a very interesting time when we had crocodiles up on the North Pole. We had palm trees in Seattle. We just had this wonderfully tropical climate. The bad news is that sea level was 240 feet higher than it is now because there was no ice. There were no ice sheets at all on the planet.
And when was that?
This was about 50 million years ago, but we only have to go back 110,000 years ago to see a world where sea level was at least 10 feet higher than now. And there's great evidence of this in Florida. In the Florida Keys, there's a beautiful quarry in Windley Key. It's a national park. And you can see big coral heads sitting 4 or 5 feet above sea level. Now, if you go offshore with your mask and flippers, you find the same corals, big Montastria they're called, living down about 10 feet deep. That's the shallowest they can live. So here is evidence, and we can date these with radiometric dating, that 105, 110,000 years ago, sea level was 10 feet higher than it is now, and the entire geography of that place was different. What caused that short-term rise, and this was a blip in the Ice Age, was orbital changes. But at the same time, we had a slight increase in carbon dioxide, and these two conspired to cause a great melt, enough to produce a 10-foot rise in sea level.
And that concludes our interview with Peter Ward, author of a disturbing new book called The Flooded Earth. And stay tuned now for the second half of Exploration, where we're going to continue the discussion with David Archer, author of yet another disturbing book called The Long Thaw. Welcome back to Exploration with Dr. Michio Kaku. In the first half hour, we had a very disturbing interview with Professor Peter Ward, author of the book The Flooded Earth. And in the second half of Exploration, we're going to bring on David Archer, author of the book The Long Thaw. And once again, if you want a copy of today's program, you can call the Pacifica Program Service at 1-800-735-0230. Well, without further ado, let's bring on our next guest, David Archer, author of the book, The Long Thaw. And now I'd like to introduce our special guest for today. He's Professor David Archer, Professor of Geophysical Sciences at the University of Chicago, and he's the author of a rather disturbing new book, and it's called The Long Thaw, How Humans Are Changing the Next 100,000 Years of Earth's Climate. He argues in The Long Thaw that not only are humans ruining the atmosphere of the Earth by dumping copious quantities of carbon dioxide, but the effects of this will linger in the atmosphere, not just for years, not just for centuries, but 100,000 years. And what does it mean? What does it mean for us to live in a world with that much carbon dioxide and that much global warming? So once again, the special guest is Dr. David Archer of the University of Chicago. The book is called The Long Thaw. Professor Archer, as a youth, how did you first get interested in science, and in particular, earth science?
I guess I looked to the Earth, the functioning of the Earth, the stable geochemical cycles of things like that, as something that's bigger than people are. I look to the natural world with a sort of reverence, and I think that's what brought me into the natural sciences. Why I chose to study the oceans, actually, instead of forests or other planets or stars or something like that, is because I've always had a romantic love of boats. But now I ended up living in Chicago anyway. But that's just one of life's jokes, I guess.
Okay, well, let's get right into it. First of all, what is the relationship between carbon dioxide and global warming?
Well, carbon dioxide traps infrared light that tries to leave the atmosphere. It's like if you put a coat on in the wintertime, it traps some of the heat leaving your body, and so it allows your body to warm up. And the theory about CO2, how it affects the climate of the Earth and how much it affects the climate of the Earth, is over 100 years old now. It's very, very solid science. That if there were no greenhouse effect, we wouldn't be able to explain why the Earth isn't in a deep freeze, or the climate of Venus, or lots of other things. It's very solid science.
And, well, talking about Venus, some people call Venus the greenhouse planet. Why would a carbon dioxide atmosphere for Venus make it the greenhouse planet?
Well, there's 70 atmospheres of CO2 in the atmosphere of Venus, so it's very, very thick greenhouse forcing. It has a very strong greenhouse effect. Actually, Venus is also a very reflective planet. That's why it's so bright in the night sky. So if there were no greenhouse effect on either Earth or Mars, even though Venus is closer to the sun, it would be colder than the Earth because it reflects away so much of the sunlight that would heat it up.
Okay, well, now let me play devil's advocate. Some people say, bah, humbug. The current warming of the Earth is a natural cycle. The Earth is naturally warming up. Other people say that it's the sun. Yeah, the sun. The sun is causing the Earth to rise in temperature, not human activity. And other people say that the Earth is cooling. What are your thoughts?
Sometimes it's even the same people who one year say the Earth is not warming up, and the next year say that it's warming up, but it's entirely natural. You know, ours is a contentious species. We tend to take both sides of positions, even if there's nothing to base assertions on. If they sound good, they still can carry some weight. The Earth has clearly been getting warmer. That's measured, even though it's been a cool summer here in Chicago. Overall, the average temperature of the Earth is rising. The sun has not been getting brighter. We have good measurements of the intensity of the sun from satellites going back a few decades. I don't know exactly, but it's not. There's a sunspot cycle that makes the sun brighter and cooler over 11 years, but there isn't a long-term trend at all in the sun getting brighter. So, you know, people say what they, think people want to hear, and people hear what they want to hear, but there is, objective reality. We can measure these things and say what's really going on.
Okay, well, some of the critics say, okay, so maybe the Earth is getting warmer. However, human activity, some people would say, no, it's not human activity. So what's the reason that many scientists believe that it's human activity causing the current warming?
We can estimate how much warming to expect from rising CO2 concentrations in the air. That's actually boiled down into a number called the climate sensitivity, which is how much the climate would warm if you doubled the CO2 concentration. And the first estimate of the climate sensitivity of the Earth actually goes back to Svante Arrhenius in the year 1896, over 100 years ago, who predicted that doubling CO2 should raise the temperature of the Earth by about 6 degrees centigrade. And now they say it's something like 2.5 to 5 degrees centigrade. It's really not that much of a change. It's a tricky calculation because it's very complex the way that CO2 interacts with light. But this is, by sort of normal non-political rules of science, this is a done question.
So if you, let's say, were to remove humanity from the planet Earth, then you're saying that the Earth would not be so warm as it is today?
There was a model exercise conducted by the Intergovernmental Panel on Climate Change. So these are climate models developed all over the world, and they all subjected their models to one scenario where you tell the models about the rising concentrations of greenhouse gases, and then another scenario where you only have the natural climate forcings like the intensity of the sun or volcanic eruptions can cool down the planet. And if you tell the models about the greenhouse gases, they can explain the warming that has been detected since sort of the 1970s. The temperature since the 1970s, that's the smoking gun for global warming. If you don't tell the models about the greenhouse gases, they don't warm up in the same way. So if you want to say that the warming is real, but it's caused by something that we don't understand in the climate system, which, there will always be things that we don't understand, not only would you like to come up with an explanation of what that something would be in order to settle the question, but you would also have to figure out why the CO2 is not causing the warming that we attribute it to. It's sort of like if you catch, I make an analogy in my classes to a murder mystery, because people always put on their thinking caps when they're reading murder mysteries. They don't always put on thinking caps when they're thinking about science. But so you catch the butler with a gun in his hand and the dead guy, and there's smoke coming out of the gun, and your partner is sort of a contrarian guy. You're a policeman trying to solve the crime. Your partner says, "Well, I think the chauffeur did it." But for your partner to convict the chauffeur, he's first going to have to explain to the jury what the butler was doing with the smoking gun in his hand. In other words, translating back out of the analogy, if we want to say that the warming is not from CO2, we have to explain what's wrong with greenhouse theory, that the CO2 should not be causing the warming.
Well, if you look at temperature rises over the last many centuries, you see a gradual warming, because after all, there was an ice age 10,000 years ago. But some scientists say that there's a spike that is quite anomalous that is taking place in the last 100 years, and that's proof that it's human activity because it's not part of the natural cycle. What are your thoughts?
Well, there is this large-scale glacial interglacial cycle that you refer to. There's also a sort of a milder, much shorter, I don't know if it's a cycle or just sort of fluctuations, but back sort of between the 1300s and the 1700s was a time of generally cool temperatures called the Little Ice Age. So you could, ice skate in Amsterdam and things like that you no longer can do. And that is correlated with a lack of sunspots, which indicates that the sun was cooler. We don't have satellite solar intensity data going back to the 1600s, but we have observations of a number of sunspots that date back to, Galileo's invention of the telescope in the 1600s, and there's a correlation between the number of sunspots and those sorts of climate changes. I think the evolution of climate up until the 70s, though, can be explained pretty well by natural forcings. It isn't until the 70s that the climate signal the human forced climate signal started to come up out of the noise of natural variability.
Now, also, some people say that the last decade was perhaps the hottest decade ever recorded. How far back does that go? Because, of course, perhaps during the dinosaur era, things were a lot warmer back then.
Sure. So there are thermometer records that go back to about 1860 from Fahrenheit's invention of the thermometer. They can piece together the temperature of the Earth going back further than that with what they call proxy records of temperature from the widths of tree rings or from chemical measurements they can make in ice cores or sediment cores or something like that. And so they can figure out that the Little Ice Age was cooler, and then there was a period of general warmth before that called the medieval optimum climate. Those records generally go back 1,000 or 2,000 years, and the conclusion of the last IPCC report, which summarized climate, for non-specialists and for the community outside of your own field, very useful, very, very authoritative reports. They concluded that current temperatures are warmer than they have been in 1,300 years. But if you go back millions of years, you're absolutely right. During peaking about 50 million years ago, the Earth it felt tropical to the poles, and there was no ice anywhere to be found. And this is thought to be due to higher CO2 levels in the atmosphere at that time. We don't have as good ways of estimating what the CO2 concentration was when you go that far back in time, but the evidence that has been pieced together is all consistent, that there's sort of million-year or tens of million-year fluctuations in the natural CO2 levels of the Earth that sort of drifts up and down like that.
Now, scientists that have gone to the poles to extract ice cores, essentially getting ice that was deposited perhaps several 100,000 years ago to maybe 1 million years ago.
Yes.
They see that carbon dioxide levels and temperature levels go up and down in unison like two roller coasters. What does that mean?
It's rare that you find such beautiful correlations in nature, I think. It's just astonishing. Al Gore showed this plot in his movie. That's sort of how iconic it is. It's an astonishing thing.
So, Professor Archer, ice core data shows that carbon dioxide levels go up and down. But the temperature of the Earth goes up and down, and the two of them go up and down like two synchronized roller coasters. So what does that mean if the ups and downs of carbon dioxide exactly mirror the ups and downs of temperatures on the Earth?
Somehow, the orbit of the Earth around the Sun has these wobbles in it, and that is thought to pace the progress of the ice age cycle, when the ice sheets are going to grow or when they're going to collapse. But somehow the CO2 concentration of the air follows along with the changes in the climate, so that when the orbit tells the ice sheet to make the Earth warmer, the CO2 says, okay, I can pitch in some to that too, and so it amplifies these climate changes.
So which comes first? The temperature rise comes first, and then the carbon dioxide rise, vice versa? What's the relationship?
It's a back and forth cause and effect. It's a feedback system. So to ask which one is driving which, I think, is like asking if you see two figure skaters, twirling each other around on the ice, to try to analyze the trajectory of one without paying attention to the other would make no sense. On the deglaciation, the transition from the Ice Age climate to the present-day climate, the first thing that started to happen, as recorded in the Antarctic ice cores, is a change in temperature in Antarctica. And then a few centuries later, the CO2 concentration started to rise. But then the total change in climate took much longer than a few centuries. So there's no way you could explain the climate transition from the glacial world to the interglacial world without taking into account the change in the CO2 concentration. So it's a feedback loop of cause and effect. It isn't just one or the other drives the thing.
So, summarizing, if you were to go back 10,000 years, we had the Ice Age. Things have been warming up in the last 10,000 years. But is it safe to say that recently, in the last several decades, there's been a spike in temperature rise, and that's due to human activity?
That's more or less true. Actually, the interglacial period is called the Holocene. And the early Holocene, right at about 10,000 to 6,000 or 8,000 years ago, may have been warmer than today. The Earth's orbit around the Sun was in a different, slightly different configuration than it is today. So it almost seemed like there was a peak in warming, and then maybe a little bit of gradual decline driven by the Earth's orbit over the millennia. But certainly over the last 1,000 years or two, the temperatures of the last decade are anomalously high.
Okay, let's talk about the present. What's happening with glaciers and the North Pole and the South Pole? We see evidence of the melting of the glaciers around the Earth. That's why scientists are finding so many mammoth bones and even human remains because the glaciers are receding. So what evidence do we have that the Earth is warming?
Well, we just have the thermometers. I mean, for direct measurements of temperature, thermometers are hard to beat. But the mountain glaciers are almost all melting. It's difficult for a glaciology graduate student to find an advancing mountain glacier to study anymore because there are very few that exist. There's warming detected in the deep ocean. Fairly deep, not all the way to the bottom of the ocean, but you can see the warmth sort of penetrating the ocean. In the high latitudes, the Arctic is melting like crazy. It's the sea ice covering the Arctic Ocean is melting much faster than any of the models a few years ago predicted. The year 2007 was a sort of a train wreck for the sea ice up there. It just plummeted. Actually, in the southern hemisphere, it's not so clear what's going on. In the interior of Antarctica, it actually is cooling, which is not. That's something that the climate models also predict. So that's not a discrepancy. But there's also not been a melt back in the sea ice in the Antarctic either. And I gather there's still some messiness about that issue, that maybe it's caused by changes in the circulation of the atmosphere caused by the ozone hole, which is a completely different sort of phenomenon. Ozone is a greenhouse gas, but it also absorbs ultraviolet light, and so it heats up the air that it's in the stratosphere. That's why the stratosphere gets warmer as you go higher up in the stratosphere, because of ozone. So by wiping out the ozone in the spring of the Antarctic every year, that changes the dynamics of the air, and maybe that's responsible for a lack of global warming signature generally in the southern hemisphere. Actually, there has been very intense warming on the Antarctic Peninsula, which kind of sticks out from Antarctica up into the slightly lower latitudes. And so you read sometimes in the newspapers about these ice shelves, these very thick floating shelves of ice, hundreds of meters thick. You could walk on it and not know that you weren't on solid land, that suddenly have been collapsing. Places that have been covered by ice for, since the last ice age, suddenly are ice free. So there are signs of the climate change every place. The growing seasons have gotten longer. The Arbor Day Foundation has published maps of climate zones of where you should plant begonias or tulips or whatever, and those have changed since 1990. There are all kinds of signs. It's more obvious in some parts of the world than others. Actually, in Chicago, there hasn't been much climate change since the 70s, but if you go up to Alaska, the climate changes have been huge. So, local experience is not necessarily a good guide, but you put it together into a global average, and it's very clear.
And also, you mentioned how it affects plants and also animals with the changing of the growing season, but also insects, right? Some people are saying that the West Nile virus, which has been spreading through urban centers, is in part driven by global warming, and then in the future, malaria could also spread. What are your thoughts?
I'm not a public health person. I don't really know a lot about the details of this, but people that I talk to are very concerned about the effects of climate on public health. I think the World Health Organization estimated last year that there are 150,000 deaths a year that can be attributed to climate change. Now, obviously, that's a statistical sort of question that's not so easy to answer. But the people that I talk to say that's a very realistic. They have models of disease transmission and everything, and the climate and the insect vectors that carry the diseases are part of those models. Now, that being said, you can do a lot about malaria itself just with mosquito nets and insecticides and things like that. And so I have heard the argument that instead of paying to reduce CO2 emissions, we should just pay for mosquito nets. I don't think the tropical diseases are the main reason why we want to worry about changing the climate.
Okay, now let's talk about the thrust of your book, which talks about the future, up to 100,000 years into the future. Well, first of all, let's talk about the coming decades. What's happening with the temperature on the Earth? Projections out to 50 years, 100 years. Some people say that on a scale of decades, major metropolitan cities like New Orleans, Boston, New York, San Francisco could be partially underwater. So what are the projections for, let's say, 50 to 100 years?
Well, one of the big uncertainties there is what we do with CO2 emissions and energy, but you can take as a baseline just to talk about what they call a business as usual scenario, which is a projection of how much energy people will need and how much fuel they will burn to get it if there were no constraint from changing climate. And temperature changes responding to that would put the Earth warmer than it has been in millions of years. So saying what exactly the impacts of that would be on, the corn harvest in Iowa or something like that is really not a very easy thing to do. With respect to sea level, the question is all how quickly can the major ice sheets respond to the changes in climate? The models that have been developed in the past don't respond nearly as strongly as the observations that glaciologists actually can make in Greenland and Antarctica about how the ice streams flowing into the ocean respond to the changes in climate. You can measure more ice quakes in Greenland with seismometers than you could 5 years ago. And the ice sheets, the ice streams flowing from the ice sheets into the ocean are accelerating. So it's really kind of anybody's guess how long it takes for sea level to change. There were events in the past called Heinrich events when the Laurentide ice sheet, which was in North America, every 8,000 years or so during the last ice age would just collapse into the ocean. And there would be this armada of icebergs in the North Atlantic, and they would carry little rocks and sand and stuff like that would then deposit on the seafloor, and there's no way for those to get there other than these icebergs. And so that's how we know about these events today, is by finding those layers of rocks on the bottom of the Atlantic. Those seemed like they took a century or a few centuries, and they seem, some of them, to have raised sea level by many meters, which is much more than any of the ice sheet models predict for the global warming climate event. But I think a lot of people, most everybody, thinks that these ice sheet models are just lacking some essential physics at this point.
Well, some people say that the real problem with sea level rise is simply the thermal expansion of ocean water with the rising temperature of the Earth. And since the Earth is rising in temperature, the oceans are going to expand no matter what happens to the North Pole or the South Pole.
Well, that's absolutely true, and that's part of the forecast for sea level rise by the year 2100, which is about half a meter or so. Something like half of that sea level rise is caused by exactly this effect, the expansion of the seawater. It's like the mercury in the thermometer that fills up more of the thermometer when the temperature goes up. That's a process that will keep going for centuries. So the forecast for the year 2100 is not sort of the end of the line. That's sort of just the beginning for the thermal expansion of seawater. The other half of the sea level rise that's actually in the IPCC forecast for the year 2100 is melting of smaller mountain glaciers like in the Andes and the Alps. And actually a lot of the sea level rise today can be attributed to mountain glaciers in the state of Alaska. It just happens to be a place where there's lots of ice frozen on mountains and where the climate changes are very intense. But it's some astonishingly large fraction of the sea level rise comes from Alaska.
Okay,
just as a curiosity.
Okay, so what does that mean for the average person who has to make decisions, enormous decisions, in the next few years about fossil fuel consumption, about investment in solar energy, and so on and so forth? What changes in their lifestyle should we expect in the coming decades?
Well, lifestyles could change because we adapt to new energy technologies. Most of the CO2 emissions that can be avoided in the next few decades actually come from improvements in efficiency.
Well, unfortunately, that's it for exploration. Once again, we had two special guests today. The first special guest was Dr. Peter Ward, author of the book Flooded Earth. And the second guest was Dr. David Archer, author of the book The Long Haul. Good day.